Greetings, my name is Steve Miller. I'm a professor of mathematics at Williams College. I teach classes that are for the most part either in pure mathematics or in statistics and applied mathematics. So I teach a lot of classes such as probability, and I'm really looking forward to teaching Introduction to Data Sciences in summer 2019. So most of my research is split between trying to develop theories and trying to see how to apply them in the real world. So in addition to standard papers in number theory, I've actually worked in fields such as marketing, geology, economics, statistics, sabermetrics, baseball mathematics, to name just a few. So my area of concentration for the course is going to be the week-long unit on linear regression, or the method of least squares. So the idea is to gather some data, and given that data, try to figure out what kind of relationship you have between the input variables and the observed output. So there's a lot of great examples where you can use observed data to try to sniff out physical laws. One of the examples we'll talk about is Kepler's third law of planetary motion, and see how his observations about orbital periods and lengths helped pave the way for Newton to get his universal law of gravity. Another example we'll discuss is the German tank problem, to give you an example of how the concepts you're looking at can have real-world applications. During World War II, it was essential for the Allies to know how many tanks the Germans were producing and how many were in different theaters of war. And they had two ways of doing this. One was to use spies and espionage to try to figure out how many tanks the Germans had. And the other was to look at the aftermath of a battle, the number of tanks on the ground, and look at their serial numbers. And since the serial numbers were frequently consecutive, by looking at the observed serial numbers and using some methods from statistics, the Allies were able to estimate quite well how many tanks there were in the field, significantly better than the spies were able to do. So in our section, we will talk about basics of programming. How do you set up a problem? How do you create a simple code to simulate the real world? How do you analyze that? And then how do you apply that to the real world? So another example we might discuss is I serve on a regional school committee, and how do you use linear regression to try to figure out ways to allocate millions of dollars in funding between towns? So as you can see in the background, I am also a fan of many things such as Legos and Rubik's Cubes. I love using these as examples of trying to illustrate the power of the right perspective to look at things. So for instance, here is a standard Rubik's Cube. If you know how to solve it, that's wonderful. Here is a cube that looks very similar. It's a similar size, but if you look at it, you can see it's only 2 by 3 versus 3 by 3. And if you look really closely at the top, you can see a very different pattern with some triangular sides. It turns out this cube is almost the same to solve as this one if you can adopt the right perspective. And often things can be misleading. It looks like this is the red face. It looks like this is the green face, similar to the green face over here. But this is not really the face. When you look at how this cube works, I can turn it this way, this way, this way, and so on. I have different ways like this. If I try to turn this cube in a similar way, well, it doesn't line up properly. I can't quite turn it that way. But if I hold it at an angle, at a 60-degree or 30-degree angle, now all of a sudden this spins exactly the way this one spun. And so the ideas of how to attack this can apply to this one. And I love using this as an example of how frequently you have all the tools to solve a problem, but the challenge is finding the right perspective, the right way to look at things. So looking forward to discussing these materials with you in greater detail as the summer progresses.